where we just talk about the distance away. There is actually a formula to find reference angles. If you are more familiar or want to use that formula instead. The issue with the formula is that the formula has a couple different versions depending on where the angle is, and that can make it real annoying real quick. Yes, sir. Oh yes, homework problems. Please place over here on this empty table next to Ebony and Chloe. Homework problems, all 6 of them. Let's review. So, we have what we call reference angles. And we have coterminal angles. So, coterminals. I'm going to start on the bottom and work my way up. Because I'm silly, you should have gone the other way. For coterminals, you can find these by either adding and subtracting 360. So I'm going to use some notation here. I'm going to take my angle, which I'm going to call A. A stands for angle. Sure, why not? I couldn't think of a better letter. I take my angle A, and if it is in degrees, I add or subtract 360 degrees to find the new coterminals. Remember, you add 360 to find the positive or counterclockwise coterminals. You subtract 360 to find the clockwise or negative coterminals. So I take my angle, add or subtract 360 degrees, I find a new coterminal. The properties, that's really important to maintain here for each case, is that these will have the same, exact same trig values. So one of our homework problems, I believe, was 150 degrees. I believe, am I remembering correctly?
No.
150 degrees?
No.
What was it?
Which one though?
I think it was number 2 that I'm thinking of.
Negative 90.
Negative 90, perfect. So on our homework problems, negative 90 degrees. To find the coterminals, we would add or subtract 360. I'll start by adding 360. If I add 360, I would get positive 270 degrees. If I subtract, negative 480 degrees. That's not right. Douglas, what are you doing? 450 degrees. Now, here's the thing. The trig values for all of these will match. If I type into my calculator sine of negative 90, I will get a number. In that case, that number would be negative 1. If I type in sine of 270, I will get negative 1. If I type in sine of negative 450, I will get negative 1. They have the exact same values. No difference, no change whatsoever. Exactly the same. For the radian version, take that same angle and add or subtract 2 pi. This can be a little bit trickier, so there's no shame in having to convert to degrees, but make sure if you start the problem in radians, end the problem in radians. Just like with the degree, though, because they're the same angle, they will have the same values. The tangent of pi over 6 has the exact same value as 13 pi over 6. It's the same thing. The tangent of 0 has the same value as the tangent of 2 pi. Because they are the same angle, same location, coterminal, they have the same trig values. This is always the case. Now, reference angles are a slight variation on this. These are the ones that will have similar values. Not exactly the same, similar. Do you write this? This is the distance away from the x-axis. The distance away from the x-axis. So that's how far we are away from any single part of the x-axis. And it is assumed for this type of problem that this will be the shortest distance when possible. Always the shortest value. So if to get to the x-axis I could go 60 degrees or 120 degrees, I'm going to take the 60 as my reference angle. Now, these have similar properties. Similar here in quotes. Meaning that if for a particular angle I have a value of 1/2, the references to that angle will have either 1/2 or negative 1/2 as their only 2 options. Because references always have a similar solution. There are only 2 possibilities. The positive version or the negative version. This is how these components work together. Now, in terms of formulas, because I know some people are big on formulas, they like the formulas because it makes it simpler. There is a formula to always find reference angles, but it's based kind of on quadrant. So as a reminder, our picture. We have from algebra 1, first quadrant, second quadrant, third quadrant, and fourth quadrant. If you wish to have a formula, sadly, there's no one formula that will do all four. However, there is a formula for each one. That does not make it sound any nicer. I apologize, but the concept stays the same. In the first quadrant, if you're looking for reference angles and you are currently in the first quadrant, congratulations. They're the same thing. So, in the first quadrant, they have the same solutions. So, in other words, if I look at my unit circle, the reference angle of 30, 30. Reference angle of 45, 45. Reference angle of 60, it's 60. Even non-unit circle numbers have this property. The reference angle of 37.6 is 37.6. It's in the first quadrant, same values. In the second quadrant, and again, this is a general formula. For some, it's easy to just do it mentally like we did last time. For others, this formula can be a good fallback plan. In the second quadrant, you either take 180 minus our angle, or we take pi minus our angle. I can prove it. Let's take a look at some of the ones we had last time, like 120. According to our picture, that is 60 degrees away from the axis. I can check that. Well, I can just plug in the formula. I plug 120 into the formula. 180 minus 120, 60 degrees is my reference angle. It's how far away it is. This little formula guarantees your solution, no matter how complex the number is. So, for example, if I was to ask you about, say, 97.1 degrees, what's the reference angle? I can plug 97.1, since it's in the second quadrant. I can plug it into this top formula and get a solution. If I asked you about 4 pi over 7, I could find that reference angle by plugging into this formula because it's in the second quadrant. It could be done. It just takes a formula to do it with. And again, for some, you can do it visually. Like with the ones in the unit circle, I don't expect to ever need these formulas ever. Because you're going to look at it and be like, there's only 3 possibilities. 30, 45, 60, or the weird ones, the 90s and the zeros. Third quadrant, we either do the angle minus 180 or the angle minus pi. And again, I can do that pretty simply by checking out with the unit circle numbers. In the third quadrant, our numbers like 210, 225, 240. If I plug any of those into that degree formula, I will find the reference angle value. Plug in 210. 210 minus 180 is 30. That is the reference angle for that. And I can see in my picture, it is clearly 30 degrees away from this axis. It has that gap. And if I even do it in the radians, it has the same property. If I take 4 pi over 3, which is also in the third quadrant, because it's in the third quadrant, I can subtract pi from that. I will get pi over 3 as my value. And I do get the solution. Now, fourth quadrant, you'll notice that as we go farther along, these get more complicated. It's because the angles get bigger. There's no good ways around that. Last one. Fourth quadrant. Garrett, what did you say?
360.
360?
Would it be minus the angle?
Yep.
Yeah.
Or 2 pi minus the angle.
We don't have to do this. We can just look at it.
Yes, you are exactly right, Levi. You do not have to do these steps. This is a fallback if you are struggling with them. You'll start noticing in upper math a lot more often the formulas are fallbacks on other concepts, not the main thing you can do.
Is there a degree that's not on the unit circle that I don't know about a minus? That's why we have.
If it's not in that listing, guess what you got to do? Coterminals to put it in this first list. Example, if I have an angle like, say, 700 degrees, this listing won't do 700 degrees.
Subtract minus.
I can subtract 360 to get it into this listing, which would have 340. And then 340 is in the fourth quadrant. To find the reference angle, it's 20 degrees. It's very straightforward, very simple. That's why we learn both these together. It's because you can combine them together to find every angle relationship you can talk about.
Is this what we're doing?
Mm-hmm.
Oh, so we're literally doing exactly what I said. The same thing we did.
No, we took a little more steps.
Well, I mean,
Well, actually,
It's exactly.
the difference is
You just gave us.
these will not be as nice.
yeah,
They won't be as nice. So, with yesterday, ones we talked about were primarily unit circle ones, so they're relatively easy to visually just look at it and give an answer to. Those we're going to talk about today, you're not so kind. For our process today, here's my recommended steps if you cannot find them by the techniques we talked about yesterday. Step 1. Your steps for today. Step 1. If your number is bigger than 360 or less than 0. In either case, I want you to use coterminals to get it to a nicer value. That is not a requirement, it's a suggestion. These are your suggested steps for the day. Use coterminals to move your values around. Especially if your number is really big, which at least one of your homework problems will be a large value. Like if I give you a value that's in the thousands, good luck trying to fix that into the unit circle. You've got to put it around by you find those coterminals until it gets to something nicer and easier to work with. So, adjust it. Otherwise, move on. If it's already between 0 and 360, you're good to go. Okay? If it's between 0 and 360, step 2. Determine the quadrant. Determine what quadrant you are currently in. And again, this is a fallback plan. If you already can do it visually, then do it visually. This is meant to be a fallback if you get stuck or are finding you're getting the wrong solutions. Determine the quadrant. If you can determine the quadrant, you can find the formula to plug it into. Last step, plug into the formula. So, these problems, it's important to note that anytime we talk about these are suggested steps you could do if you're not able to get them without these steps. And again, the way it works, get it into this first step between 0 and 360, or the alternative between 0 and 2 pi. Then, determine the quadrant you are in. Remember, the quadrants start at 0 degrees, 90 degrees, or 2 pi, or pi over 2. 180 degrees, or pi. 270 degrees, or 3 pi over 2. And then ending at 360 degrees, or 2 pi. Determine the quadrant so you can plug into the angle formulas. If not, what one do you? There are plenty of people who do not ever need to use these formulas. I won't know which one you are, so that's why I give you the formulas in case you do. So, let's look at some practice problems. See how these work, fit together. The idea is we're going to determine the reference angles, just reference angles tonight. Just reference angles. The reason that it's just references is because you're going to have to do some coterminals for some of these already. I'm not going to make you do more. So, find the reference angle for every angle I gave you tonight. Many of these will be not nice.
How many of them are there?
10.
Okay.
So that means they're going to be really not nice if there's just.
So, I can't help giving you some nice ones. It was a smile that was just under here. You couldn't tell. Okay. Before we start our first example, do we have any questions? I shall give that last warning one more time. These formulas are not a requirement to do the problems. They are a helpful way to do them if you're getting stuck or getting wrong solutions. These are a fallback plan. If you can look at it and go, clearly I got the answer done, and you're getting them right, these formulas are not necessary. Use them only as needed when they need them. Here we go. Some examples. Example. How about, let's start off in the unit circles list, so 0 to 360. Let's talk about 237.6 degrees. For every problem tonight, I want you to find the reference angle for me. Now again, as we discussed, reference angles will have the same properties or similar properties, depending on the location. Either be a positive or negative version of the reference angle property. So, sine of 237.6 is going to equal or be similar to sine of some value between 0 and 90. Here we go. I'm not sure what to do here, so I'm going to follow my steps. Just like I said, it's a good fallback if you get confused. Step 1, is it bigger than 360 or less than 0 and you can coterminals? Turns out step 1 I can skip for this one. Okay, I have no adjustments to be made. It's already between 0 and 360. I'm good to go.
Oh, we have to figure out the question.
Step 2, quadrant. So for me, whenever I do these kinds of problems, you'll find, as weird as this looks, in the corner of my paper, I will draw it out. It is not because I can't do it in my head, it's because I get annoyed. I will draw out my unit circle. Not the full unit circle, just the ones that matter. So I can decide quadrants. So, got 1, 2, 3, and 4 in the third quadrant. So this one should be third quadrant. So I'm going to take 237.6 degrees, subtract 180. That's my formula. That should tell me my reference angle. In this case, cool. You already find it? What is it, Matt? 57.6. 57.6 is my reference angle. I'm done with the problem. Which means, okay, for a lot of the examples we're going to do today, we're going to test them. Because on the ones we had in the unit circle, we could look at them and verify, oh yeah, this one's 1/2, that one's negative 1/2, they're the same. Or similar properties. Here's what I want you to do. Let's see, Jacqueline, I see you got a calculator. Would you mind pulling that out for me? Make sure it's in degrees for me. Luis, do you have a calculator with you? Please grab that out. Now, because these are not on the unit circle, these will often be nastier values. That's okay. The thing is, because these are reference angles, when I have Jacqueline type in one of the trig functions, sine. I'd like you to type in sine of 237.6. Luis? I'd like you to type in sine of 57.6. Now, if this is correct, if this is a reference angle, her version of this answer and his version of this answer should be similar. Not necessarily the same. They should either be a positive or negative version of the same answer. So, Jacqueline, what'd you get?
Negative 0.844.
Hold on, 237.6. You got, say again?
Negative 0.844.
Beautiful. And Luis, sine of 57.6.
I got 0.844.
So again, similar, not necessarily the same. As it turns out for this one, if you do the cosine, similar thing happens. Different values. So I think the cosine one is like 0.017 or something weird, and negative 0.017, something weird. Turns out for this one, tangent is actually the same for both of them. So again, similar for some, same for others. That's why we have these properties of reference angles, because they should be similar. Okay? This is the idea. This takes our angle list. Okay? As important as this thing sounds, just bear with me for one moment. With this property, we have taken every conceivable possible angle. Angles in the millions or the billions, positive angles, negative angles. We have reduced every angle down to something between 0 and 90. That's the big thing that comes out of this process. With coterminals, I reduce every angle between 0 and 360. With references, I reduce every angle to between 0 and 90. A much smaller list to work with. Properties that are easier to work with in general. Numbers that are easy to work with in general. So, for each problem we're going to do today in class as an example, we'll work through this part too. So make sure you got a calculator out so we can check them. So I'll be calling on random people. Let's do another one. We'll do 1 radian inside the part. And we're going to start going around. Okay. Like I said, these are just suggested steps. They work pretty well. Not required though. Examples. Alright, a radian in the part. Let's see. I want to do...
Did you go forward?
Not yet. 7 pi over 8. Bang on the unit circle. Now, these weirder ones, you are, as always, you can convert it to degrees. They may convert nicely to degrees, they may not. It's hard to tell sometimes. Or you could just try to look at it as the same pieces. So let me draw my unit circle again, release the bars. This time with the radian values. 0, pi over 2, pi, 3 pi over 2, 2 pi. Alright, question number 1. Is this bigger than 360, or in this case, 2 pi? Is it smaller than 0? No, we're good. We're in the part. That grouping between 0 and 360, that grouping between 0 and 2 pi, you don't have to do any big changes like that. So we'll skip step 1. Step 2. Step 2, what is that? Quadrant. Which quadrant is this one in?
3.
Heard 3, heard 2. Which one is it?
2.
It is 2.
Dang. I would have guessed.
7 pi over 8 is roughly right there.
It's not.
It's less than pi because the top number is great or smaller than the bottom number. It is a little trick you can use. If the top number is bigger, it's got to be in the bottom half. If the top number is smaller, it's got to be in the top half. So, it's in the second quadrant. So that means for this problem, if I'm going to use the formula states, I need to do in the second quadrant, I would do pi minus my value, so pi minus 7 pi over 8. So what is my reference angle for 7 pi over 8? See it?
1 over 8.
Yeah. 1 over 8 pi or pi over 8, any of those is acceptable. That's right. So again, I make sure it's between 0 and 360 or between 0 and 2 pi first. Use coterminals if I don't have that. I can then convert it to the correct quadrant. Once I have the correct quadrant, I can use the correct formula. I get my solution. I'm going to check this real quick. Let's see, I need 2 more calculators. These time, make sure yours is in radians. Let's see. Ebony and Scott. Ebony, if you'd be so kind. I want you to type in tangent of 7 pi over 8. So tangent 7 pi over 8. Scott, I want you to type in the reference, so tangent of pi over 8. Make sure before you do anything else, it is in radians. Otherwise, this won't work. Negative 0.414.
I just got 0.414.
There we go.
Simple.
Just for giggles here, this one, let's see. Erica, Garrett, the signs, please. Erica, 7 pi over 8. Garrett, pi over 8, please.
Yeah, you do tangent and sine.
If I'm correct in how I remember this, this one should be the one that matches. Erica, what'd you get for 7 pi over 8?
0.383.
Garrett?
Yeah.
Same thing? So again, some of them should match, some should be similar. Notice that they're not the same values, right? 0.414, 0.383. They're different trig functions, so they have different values most of the time. But the reference angles have similar ones. Always forever. I'm going to post two on the board this time. They'll both be degrees. One will be a negative degree, one will be a big positive degree. We'll do references for both. Here we go. 2 this time.
Like 2 different problems? Or?
Yep. Example. Negative. Let's go with negative 212.3 degrees. And the big positive, let's go with 968.4.
Really drastically huge, massive.
Oh, we will.
But why not now?
Shut up, Scott.
Sorry. Really? What?
You know, Scott, some people just don't appreciate your good jokes. But I do, Scott, so don't worry. All right. Now, both of these are outside our standard range, so we may have to make some adjustments using the code terminals. So remember, you can either add or subtract 360, and if it's still not working, you can do it multiple times until eventually it is between 0 and 360. Once it's between 0 and 360, we'll want to determine the quadrant. Use the quadrant to determine the formula. Again, these are suggested steps. It can be done without it, but just takes a lot more hat whack. Okay. There are, for those that may be wondering, other shortcuts, other slightly modified formulas that work in various situations. If you find you try something and it worked really well, remember that. Try it on another one. See if it still works. Because maybe you'll find it works really well for some and not for others. Those formulas are general formulas that always work and always work with coterminals. So they are a great list to know. It does not mean that the only thing. Never assume that I will show you everything because, quite frankly, if I did, we'd be still talking about reference angles in 6 months. All right. I'm going to show my work real quick. Step 1. The answer is 32.3.
Decimal. It's 147.7.
All right. Show my work.
68.4. Yes, sir.
Did you get 68.4?
Yes, sir.
Okay, let's do it. This first one, I'm going to take this. It is not currently between 0 and
Did you
360, so I'm
just
going
guess
to add 360.
Good question.
I did it in my head, so
Did
I
you
cannot be
just do that?
100% sure.
Yeah, that's correct.
Sweet. Okay. I'm going to add 360 to get this in between 0 and 360. Using, again, this is my coterminal here.
No, I did not. He knew he'd done this before.
We're
Yeah,
his
look
first
at
trick.
it.
We're his first trick class.
I mean, you can give me a random number next time. We'll see what happens. All right. So I'm going to add 360 using a coterminal. 42.4? The answer would be 42.4. Between 0 and 90. What's wrong with you?
Let's do.
Boom!
Hold on. Let's do.
Roast it. No. I already beat you. I already beat you. Okay?
300.
Oh, I got you. 317.6.
5.
Okay? So, as subtract 360, I get 147.7 degrees. That is my coterminal. That is, according to my list, that is in the second quadrant. So I would subtract that from 180. So I take 180 minus 147.7 degrees. And I should end up with 32.3. On this side, I got 68.4.
Right, she said hold up.
Sure thing. Yes, ma'am.
Why did we use 360 instead of 460?
So for this specific problem, you can get away with using a different number. I am just following the recommended steps. What you did does get you the solution. It may not always get you the solution. So try it on another problem and see if it still works. Okay, that's all I can tell you. As I said in class, there are a lot of rules that it's just not worth covering because they're so specific. Like, oh, if it's between these two values, then use this slightly different formula. Nah. Do you really want to memorize 1,000 formulas? These ones work really well as long as it's between 0 and 360. So that's what I show. There are other ways. You asked me if I did it in my head? Yeah. I did it with a shortcut that I know because I've done these a lot. Okay? 68.4.
I want to know that shortcut.
Now, I'm going to subtract, in this case.
No, I told
And instead of subtracting 360, I'm going to subtract 720. That'll also be a coterminal. I'm just going to skip out on a step.
All you do is take away the 9.
It ends up being 248.4 degrees. This is in the third quadrant. According to the third quadrant rules, what we need to do is we take 248.4, subtract 180, and that will give us 68.4.
Can you teach us your shortcut that you're... Okay, wait. First, what did we say? 317.65?
Why you gotta pick a harder one? 317.65?
Yeah.
Did you know the answer first?
42.35.
Wait.
What's the answer?
What did you say?
42.35.
42.35?
Okay, good, go.
Do I need to check that or did you have right?
I'm right.
Just check it.
Can you teach us that technique?
It's not hard. So, like I said, there's a lot of ways you can do this. One of them is, it was in the third
He
quadrant.
just did 3. No, it was in the 4th.
That's the fourth quadrant.
Okay, let me give you an example real quick
He just did 3.
that we did last time. That's going to be cut on real quick. I used the exact same one that you just did. Ready? What if I said negative 27 degrees? Not an official example. What if I said negative 27? What's the reference angle? 27. Right? Because that's how far away it is from the x-axis. Remember, you can always go back to that definition to determine a reference angle. So when you gave me a weird number like 317.65, what did I do? I subtracted 360. It put it as a negative number, which I know is going to be the same as the positive. There's so many different rules you could learn if you wanted to. Again, these are just designed to get you a good start. I would not suggest spending your life trying to find 50 more formulas for reference angles. Find a couple that work for you, like that list, works good. And make sure you're always being consistent with the right answer.
Why should I do that subtraction in your head? I can't do it.
Yeah.
That's not a business.
I mean, he does this for a living, though, so.
Okay, I'm going to do 2 rating ones real quick, and then I'll post 10 problems. Here we go. Example. Example.
Yeah, Obama says a grower.
Alright, so again, we're going to have one positive, one negative. I'm going to make this one, let's see, the positive one. 14 pi over 5. The negative one.
Baseball season.
Dude, it was bad.
Negative 11 pi over 9.
Ah, I see.
There is even nicer shortcut on some of the radical or grading ones. It's actually really nice once you figure it out, but I will not tell you that one.
What?
Because some of you guys will figure out right away and be like, oh, got the answer. And I was like, nice.
Why can't you tell us?
Why can't you tell us?
You gotta figure it out.
That's rigged.
Right. Maybe after these two, some of you will.
What?
And again, if you struggle with these particular forms, you can always try to convert it into degrees. I'll usually be able to tell though, because especially on these ones, they're not as nice to convert sometimes. And so it becomes pretty obvious that you convert it because you get a decimal answer instead of a nice fraction. Yes. As a reminder, that was a good suggestion. Thank you, Madeline. If you do the conversions, you either use 180 over pi or pi over 180.
Wait a minute. I think I might know your trick, but it doesn't seem like it should work.
Find out.
Let's see here.
Hey, Cole, did you finish? The first one?
Did you get a negative number?
No.
See how doing wrong.
Oh, I don't know.
So it shouldn't be negative.
Okay, see how I'm doing wrong.
Okay.
Reference angle should always be positive and between 0 and pi over 2 or 0 and 90 pi over 2.
We'll see if this trick works. Or if I just totally pull something out of my butt and got it wrong.
Okay. Yep, alright.
You guys anything on the second one?
I have
You
one.
did it. I got you.
I'm like,
Good question. Is the second one pi over 9?
You are close.
Close, but no signal. That means it's wrong. I
2 pi over 9.
really think you just.
That is part of it. Did you wonder?
Oh gosh.
You're gonna have to elaborate, or else I'm not gonna understand.
It's not an easy one to learn. That's why I never teach it. Those that get it will be like, oh, okay, I can do this, and they'll work from there. But those that don't will hear me say the cheat, and they'll be like, that's not a cheat. I did twice as much work thinking about what you just said. That it actually doing the
I
job.
feel like I got like half of it.
Yeah, it does work. Okay, so on this one, first of all, this is not in the first quadrant, so I'm going to take the first step, which is going to be to subtract 2 pi. So 14 pi over 5. I'm going to subtract 2 pi, but do not forget, if I want to subtract or add fractions together, they must have the same denominator, so I cannot subtract 2 pi. I'm going to instead subtract 10 pi over 5. That is equivalent to 2 pi, which makes this become 4 pi over 5. That is in the second quadrant. So I would take pi minus 4 pi over 5 and end up with pi over 5. Because remember, pi would simply become 5 pi over 5. You may need to brush up on some of your fractional rules if you're going to do it in the radian form. Otherwise, convert it into the degree form and then work backwards to make sure your answer is still in radians. This one. The way I did it was, I found the quadrant first and then used the coterminals. It's a little weird. It's a common trick. What you can tell, as probably Garrett was quick to note, but did not know how to use it. What did you know?
That it's like pi over the bottom number.
Yeah, it'll always be some variation. The bottom number is going to stay. In radian form, the bottom number always stays. The question is, what happens to the top number?
Something pi over the bottom.
Yeah, something pi over the bottom number. The trick is, you're like, what's that going to do? How's it going to fit? Well, for mine, and instead of adding or subtracting 2 pi, which you can do, you'll get 7 pi over 9, and then that quickly becomes 2 pi over 9 when you go in the second quadrant. You could just subtract pi. Or add pi. Either one will work. Because keep in mind, 0 and pi have the same reference angle. So they act the same when you add or subtract them. It works much the same way. There's a lot of cheats you could learn. I would suggest if you struggle with trying to find some cheats or trying to work it out, use the rules. So that's what I'll do. I'll take negative 11 pi over 9. I will add 2 pi to that, but I cannot add 2 pi. It has to have the same base, so it would add 18 pi over 9, which gives me 7 pi over 9. This is again in the second quadrant, so I would take pi, or 9 pi over 9, minus 7 pi over 9. That's where I get 2 pi over 9. With the radians, it is often more difficult just because the numbers are not as nice when it comes to fractions. Fractional math can be difficult. Calculator can help a lot. Converting it to degrees instead can help a lot. How I feel? Alright. Let's put our 10 up here. Alright. Find the reference angle. Yep.
Homework, eh?
Eh?
Got 5 minutes.
So you shouldn't even start.
Make sure it's
I'm
not.
gonna get taken out.
If you do that other time.
Alright. Let's see. What do I want? Mm-hmm.
30,000.
Go.
Please.
Stop.
Come on. I really just want a very, very ridiculously
Give
large
him
number.
extra problems.
Yeah, make it number 11
Number
12.
as a bonus question.
Bonus, yeah,
I
let's
think
do
it's
it.
time to
It's still not big enough. I mean, you know, you're in the
Ah,
thousands.
switch.
No, why?
Listen, it's just like 3 more times you have to subtract 360 or 720.
Did you say 3,000?
No, I didn't say anything. I wrote. Boom. Good joke.
That's a lot of math.
I'll just do an extra one called number 11. And it's going to be 117,400.
Okay. There's your first 5, all in degrees. Throw 5 radians up here. See what happens.
Negative and I hit plus 360.
Are you writing? So we're having 5 degree and 5 rating.
That's rough.
These due by tomorrow.
Do Friday, right?
Oh, yes. Are you serious?
Every
So what are we
week.
doing tomorrow?
You're welcome.
Tomorrow we're going to grab calculators. We're going to do some calculator stuff. Just see how these works. Clearing up some things. All right. Now I need 2 big numbers. 2 big numbers. All right. 2 big pi numbers. All right.
49 pi over 6.
Oh, that's easy.
We did it.
Let's see.
Is it mine?
All right. There are your 10 problems. I'll take a picture of this and post it in the Google Classroom as well, so we have it available to us.
I'm gonna do this next vlog.
Joe, did you send me a message during class?
What class did you have at school?
Yay.
Mr. Douglas, this is my sixth box.
I think somebody's papers were accidentally mine.
How could you? Thank you, Greg.
Yeah,
That's
accident.
all my fault.
Good job,
Oh my god, you're ready? Not gonna lose.
Why did you do the decimal? Just forget about that.
See you, Douglas. You good?
I just subtracted like 36,000 a couple times and 3,600. I use that method. Listen, I'm still upset.
Come on, Liz.
Like, there's 37 people. That's not big.
Dude, I had to subtract that at the same time.
No, all you have to do is subtract by 3,600. You're down to 126.
You guys say help.
Let's go.
That's almost exactly why I picked that number, sir.
Dude, just tell her.
If you like problem number
Tell
11,
me when she does, I will tell you.
I can give you problem number 11.
I already made a problem number.
No, you just.
It's like 117,000. So, it's pretty easy.
How about this one? You ready?
Very nice.
4,962,000. No. 4,962,000.
I'm just gonna remember 4 million. What about 360,000?
Dude, it's alright.
120.
No, that's
Yes, oil stains.
Yes, so.
Bruce.
Or
That's your girlfriend again.
360,000.
She's the one that stains them out.
60.
Oh, that's tough.
Oh yeah, I should probably turn the point off.
Yeah, she's saying.